Why, hello. This recording is about triangle congruence. Okay, the basics of triangle congruence, because there's a lot more to it than just this. Okay, this is the start of what we call triangle proofs, or proving that two triangles are congruent. So that will be the next one. But for now, let's just talk about basic triangle congruence. Okay, so here we have the triangle symbol, and this is the congruent symbol, the equal sign with the little squiggly above it. And hopefully everybody can hear me because I don't have my microphone attached to this, but I guess we'll wait and see. So when two triangles are congruent, all of their parts are equal, of course. So we have three congruent angles and three congruent sides, okay, which is different than similarity. In similarity, the sides are not the same length, but all of the angles are equal. So three equal angles, three equal sides. So if we're given that triangle ABC is congruent to triangle XYZ, we have to list all of the 6 things. So there are 3 angles that are congruent, and there are 3 sides that are congruent. Okay, and it goes like this. So angle A, the first letter here has to match up with the first letter over there. So we have angle A is congruent to angle X. Okay, the second one, the second letter has to match up with the second letter. So we write these as they correspond. Angle B would be congruent to angle Y. And finally, angle C matches up with angle Z. So angle C is congruent to angle Z. Okay, now this will be important when we start given a triangle and writing a congruence statement. So once again, this is called a congruence statement. Okay, congruence statement, that this triangle is congruent to that triangle. So on to the sides. The sides are, of course, just 2 letters together. So side AB over here, and a side is a segment, so we draw the line on top, is congruent to side XY over here. Okay, the first 2 letters of this triangle correspond with the first 2 letters of that triangle. Okay, and so on and so forth. So BC will be congruent to YZ, segment YZ, and finally segment AC is congruent to segment XZ. Okay, so segments are congruent, angles are congruent, their measures and their lengths are equal. So we write the congruence symbol. Okay, so when we're proving these things, in order to justify that 2 triangles are congruent, you need to find 3 different things about them. Okay, and there are 5 different ways that we can do it. Okay, 5 different groups of 3 in order to show that this triangle is exactly the same as that triangle. Okay, that's going to be on the next slide. So the first way that we can do it is if we have 3 sides. Okay, if there's 3 sides of this triangle are congruent to 3 sides of the other triangle. Okay, that means that these triangles are the exact same. So because they have 3 sides that are the same length, if you were to cut up 3 different, or rather 6 different lengths, or 3 different lengths and try to put them together, you can only make 1 triangle out of them. Well, they have to be 2 triangles. So because you have 3 sides that are congruent, the angles have to be congruent also. So if you could show that 3 sides, in other words, this is called the side postulate. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are together congruent to each other. Okay, so one method is by showing that 3 sides are equal. Okay, another method is by showing that 2 sides are equal and the angle in between them. So in this case, the angle has to be between the congruent sides. So let's see, the congruent angle is between the congruent sides. Hence, angle side angle. Okay, and this is also a postulate. Okay, so if I had this side and let's say this side. So here are two sides that are congruent. The angle has to be this angle, the angle in between the two congruent sides. In order to have side, angle, side, the angle must be between your congruent sides, SAS. Okay, so we could have three sides, like over here, or we could have two sides and the angle in between them. So if this side were the same length and you had this one at a certain angle, this side must also be the same length as that side. So if you could show these things, you have congruent triangles. Okay, it turns out if you have two angles and a middle side, so let's say we have this angle is congruent to this angle, and this bottom angle is congruent to this one over here. So angle side angle means the congruent side has to be here in between your congruent angles. So for angle side angle, the congruent side is between the congruent angles. And this is the symbol for congruence. Okay, so when you're doing this, you basically have to use your eyes and say, okay, where are my congruent things? Here I have two congruent angles, and my side is in between them, so I have angle side angle. Postulates. Sorry, that went off the page. Okay, the side is between your congruent angles. But also, if you have the side after your congruent angles, so maybe this angle here and this angle are congruent, and maybe we'll mark these two as being congruent. So here we have an angle, and then your side is over here, not in between it. So the congruent side is not between the congruent angle in angle, angle, side. Okay, so this is a little bit different than the last one where the angles were surrounding, the side was between the angles. Here, the side is not between the angles, but it still turns out that you can only make one certain triangle if this is true. Angle, angle, and then a side. Here, we have angle, side, angle. The side is between the angles. Here, the side is not between the angles. Angle, angle, side. This one is a theorem, the angle, angle, side theorem. Okay, and our last one, this is number 4, our last one is the hypotenuse leg theorem. And it's really important, this part right here, in a right triangle. If we don't have a right triangle, of course, we don't have a hypotenuse. So in a right triangle, if the hypotenuses are congruent and a leg, so either one of the two legs, it could be the long leg, like I am marking here, or it could have been the short leg. As long as you have the hypotenuse and one of the two legs congruent, then you have congruent triangles by the hypotenuse leg theorem. Okay, so this one, if you see a 90-degree angle and a hypotenuse, you're probably going to have the hypotenuse leg theorem as the reason. Okay, so let's look at these triangles. Are these triangles congruent? Is this triangle congruent to this triangle? And I'm going to say yes, they are. Because I notice that I have 3 sides that are congruent. So, because we have 3 sides, that's the side, side, side postulate. So they're congruent by the side, side, side postulate. And now I have to write a triangle congruence statement. So ABC is the triangle on the left. Now the triangle on the right has to match up with this one. So angle A goes with angle N, angle B goes with angle L, and angle C goes with angle M. So it's really important to match up your second triangle with the way that you wrote your first one. The first triangle doesn't matter, but the second triangle needs to match. Okay, they need to correspond, as they say. Okay, these triangles are also congruent. So let's see, we have 2 angles and the side in between them. So 2 angles and the side in between them, that means it's angle, side, angle. 2 angles and the side is in between them, ASA. So let's go with ZXY. Sure, why not? Is congruent to triangle. So angle Z goes with angle O, the non-marked side. Angle X goes with angle T. And angle Y goes with angle P. So triangle ZXY is congruent to triangle OTP because they have to correspond. Z to X to Y, O to T to P. Okay, I have a couple more examples. These triangles, notice we have two sides this time and one angle. Okay, two sides and one angle, and the angle is in between the sides. So this is going to be the side angle side postulate. So yes, these triangles are congruent by the side angle side postulate, so we can write a congruence statement. Let's go F to U to N. So triangle F corresponds with angle M. U goes with A, and N goes with S. So triangle FUN is congruent to triangle MAS. Okay, they have to correspond. FU goes with MA. Okay, a couple more. These ones, oh, here's your right angle. Sure enough, this is your hypotenuse. Okay, it's across from your right angle. So this is going to be the hypotenuse leg theorem. Okay, a right angle, here's your hypotenuse, and sure we have the short leg. So triangle OGD is congruent to triangle O goes with T, G goes with R, and D goes with A. Okay, so it doesn't matter how you write your first triangle, but the second triangle has to match up with the first one. Okay, let's take a look at this one. Here we have two angles, and the side is not between the two angles, which means this is angle, angle, side. The side is not between your two angles. So triangle LNM, L to N to M. So L goes with angle Q, N goes with angle O, and M has to go with angle P. So when you're writing a congruent statement, you have to make sure that your angles correspond. Okay, don't just write them left to right all the time. Write them as they correspond. Okay, are these triangles congruent? Well, I have one side marked. I have another side marked, so I have two sides. So the question is, can I show this third side and that third side? And that answer is no. I am not able to mark these sides as being congruent. Okay, I am only allowed to mark certain things. So I am, or rather you are only allowed to mark on your own vertical angles. Okay, in this case, I have some vertical angles. Okay, this angle here on the left side and this angle. Remember, vertical angles are those that are formed by intersecting lines or intersecting segments. So this side over here is vertical to this side over here. Okay, I'm allowed to mark my own vertical angles. So there's not much that you're allowed to mark on your own as being congruent. Some things you are, most of it you are not. So the only angles that you're allowed to mark are the vertical angles because they are always congruent and they're never marked. So now I can see that this is going to be side angle side will be the triangle congruence reason. So writing a statement, let's go with ROH is congruent to triangle R goes with R, O goes with E, and H goes with S. Okay, so if you're not marked on your triangle everything, you are not allowed to mark every single thing just because it looks like it. There's no I said so theorem, there's no it looks like it postulate. You are allowed to mark vertical angles. Okay, only. here, notice we have two triangles. We have triangle R to Y to N on the left side, and we have triangle A to Y to N on the right side. And if you notice, both of these triangles share two letters. They share letter YN and letter YN. Okay, so you are also allowed to mark sides that are shared. Okay, remember you can't mark things unless they are vertical angles or shared sides. I'm allowed to mark shared sides. In fact, we call those shared side reflexive sides. It's the reflexive property. Reflexive or shared sides. Okay, so two things alone are not enough to say that two triangles are congruent, but when we add in our congruent reflexive side marking, okay, both of these share side YN, then I have angle, side, angle. And these two triangles are in fact congruent. My side is between my congruent angles. Okay, so you are allowed to mark a few things. One of them is vertical angles. So anytime you have angles that are vertical, you can mark them as being congruent on your own. You can add them to your picture. Okay, you can also add a congruent marking on any shared side, the reflexive sides of these two triangles. Okay, so in this case here I have a 90-degree angle, which means of course I have another 90-degree angle down there. And here I have ID being the shared side. So it looks like this is my hypotenuse, and down here that's my hypotenuse. So it looks like this one can be hypotenuse leg. Triangle IND will be congruent to triangle IWD. I to N to D, I to W to D. Okay, so notice they both share the letters ID, so that's their shared or their reflexive side. Okay, you're allowed to mark vertical angles and reflexive sides. Okay, now let's look at this one. Here we have an angle and then two sides. So this one is actually not congruent. Okay, there's no angle side side, which spells a not nice word, so we're not going to write that up there. But there are two reasons. There's no side side angle, which of course backwards is a not nice word. So that's not a triangle congruence reason, nor is there angle, angle, angle. These are not triangle congruence reasons. Okay, you might have two things that are marked as such, but it does not mean that they are congruent. Okay, just because they're marked with two sides and an angle does not mean that there is automatically side, angle, side. So these triangles are not necessarily congruent. Okay, nor if they had a bunch of angles marked would they be necessarily congruent. Okay? So, once again, there are 5 reasons why two triangles could be congruent. If you have 3 congruent sides, 2 sides and a middle angle, 2 angles and a middle side, 2 angles and a non-middle side, or if you have a right triangle, the hypotenuse and the leg. Okay, in those cases, you are able to show that the triangles are in fact congruent. Okay, hopefully this was helpful, and have a fantastic day.